everyone. So in this video, we'll talk about Docker. What is a Docker? It's a kind of a container. Why we need these Docker containers? So to understand this, just first of all, think of our software development life cycle, our software development process. What we do in our typical software development process, we give a bunch of requirements and features to our programmers here, and they do some coding, they develop something, they use some dependencies, let's say some jar files, um, some libraries, and they use some framework and develop some executables, and they develop an application. It can be a Java application, it can be an Android application, can be an Apple application for an iPhone or something, or any C#, whatever Microsoft application. So based on those on on those framework uh, dependencies and libraries, they have an application now. Now they want to send all this developed application to the testers. This is our testing team, let's say, and they ship it to the testing team, or they send it to the testing team. The testers, when they install this application on their computers, they also need that framework, that dependencies, that libraries, whatever they are, jar files, whatever, and then they need to test this application. And this can happen, for example, that maybe uh, the testers miss something. They don't have any of the dependencies, that any one of the depend that you were using on your computer, and then they have problems in running this application. Or maybe there is some dependency that you had on your system but you didn't know, because maybe it was there because of some other projects already in your system, and the testers don't know which one was that. And then they say, okay, the problem is the application is not running, there is some bug in that, please go and fix that bug, and they send it back to you, and then it goes back and forth, um, just wasting time. The same thing happens when the testers, after testing the application, send it to some, let's say, deployment department, or whenever, you know, the deployment department also needs all, not only that application framework and dependencies also, but everything they need on their system. Uh, and after the deployment team has finished deploying, they of course can also send it to some customers to deploy it on their network or something, or their servers, and then they will have the same problems, because all of these different departments, they will need not only the application but also the dependencies, which were used by the programmers to actually develop this application. So how we solve this problem of, the first way to solve this problem is, one of the ways is to use an operating system, a guest operating system, like a virtual machine. Like the programmers, when they make an application, they not only send the application, but they also send the OS on which this application was developed. So if they send the OS, this can happen that, they this process will be very simplified, because this OS will have all the dependencies, all the libraries and the jar files and whatever, the framework also. This can be a Linux OS and or Windows OS or whatever, and then they can send this to the testers. The testers can, put this virtual OS on their system and then test the application, and then they can send it to the deployment team. So this is, one of the solution to solve this problem. So that's another way we can do it. For example, we will, for example, have we have an operating system on on our hardware. The developers will have an operating system, and based on this operating system, they will install some VMware or some hypervisor software that is going to, install some operating systems. It can be, for example, a Linux operating system here, it can be an Apple here, it can be a Windows 8, Windows 10, whatever versions of the operating systems here. And on each of these operating systems, for example, the developers are going to, on this virtual operating systems, they are going to develop these apps at, let's say, app 1 on OS 1, app 2 on OS 2, and app 3 on OS 2, and so on. So the developers, they develop these different apps on these operating systems, and of course they on these virtual operating systems, and of course they have installed all those dependencies on these virtual operating systems, whatever libraries or frameworks or whatever dependencies they need, whatever jar files, whatever. And then when the developers are finished with developing their applications, they send this whole package, the app and the dependencies, libs, jar files, whatever, plus the operating system, to the testing team, and then the testing team tests this, and then they send it forward to the deployment team, and the deployment team simply deploys it. So this problem is solved, of missing dependencies, missing jar and all files, and then moving of the application back and forth between test teams and the mm, uh, programmers, or the deployment and the testers and the programmers. So this saves a lot of our time. But there is a disadvantage with this, because our main topic is Docker. It's not virtual machine. So I'm explaining you virtual machine. Why? Because I want to take you to the Docker step. Why we need Dockers now? Because the virtual machines seem to have solved our problems. Well, there is a big problem with the virtual machines. The virtual machines, the problem is that with every application, you are sending the whole operating system, because the VMware software lies on the host operating system. Whatever the host operating system your computer has, it lies on that, and then it creates an operating system over this host operating system, like different OS, and then you build the application. So whenever you want to send the application, you have to send the whole operating system. So let's say you send 5 applications. So if you will send 5 applications to the testers, and they will send these 5 applications after testing to the deployment team, then this will become too heavy, because they have so many different each application will have its own operating system with all the dependencies and everything in that. So it will become very heavy, too much load. There will be a lot of wastage of resources, the RAM, the hard disk, or whatever. So the Docker's concept has solved this problem, actually. uh, So the Docker is, in the case of Docker, we have a Docker engine here just above our host operating system, and then we don't need to install these different OS. Instead, we have like containers. We have container 1, container 2, container 3, container 4, container 5, and in each container there is an app installed with all the dependencies, and then we send this container to our testing team, and the testing team send it after testing to the deployment team. So I will show you this with the picture, just like this block diagram of the virtual machine, VMware or hypervisor. So wait a second. Now here is the picture of a Docker, a block diagram of the Docker. This one, you see, as in the case of a Docker, we have a hardware and a host operating system like our computer, and then we have in place of VMware or hypervisor, we have a Docker engine here on our host operating system. And the Docker does not need any, it does not create its own different guest operating systems, but it has, it just has different apps with libraries and jar files in the form of containers. Like this is one container, this is another container, and this is another container. So if we if so the so after the application is built, it's complete, it's programmed and everything, then we send this, for example, this, if we want to send the app 1 for testing, then we send this container, we make we send a copy of this container or this container to the testing team, and the testing team then test this container, because it has all the jar files, libs and everything, and this inconsistency problem will not happen, inconsistency of the dependencies at the testing site. And the testing team will then send it to the deployment team, and the deployment team will simply install this on different of this have an image, put this image of this container at different servers. And of course, as I said, there is no this application will not have, each of these app will not have their own operating systems, as in the case of virtual machines. It is a very lightweight solution. It has so solved this problem with the virtual machines, and the reason why the Docker does not need its own guest operating system to have the app in the container is because the Docker is actually using the kernel of the host operating system. So this is very amazing. So Docker, just think of the Docker as just a container, just like this container which has an app inside it with all the dependencies, riding inside with all the libs files, jar files, whatever. And then this container is simply sent to the testing team, and the testing team then sends it to a deployment team after testing. So uh, yeah, as I was talking before, why Docker does not need its own guest operating systems is because the Docker engine is sharing the kernel of the host operating system over it resides, whereas the VMware or the hypervisor is actually making kind of an emulation of the resources of the underlying of host operating system. So it is kind of exposing the CPU, the RAM, the network, and the this resources of the underlying host operating system to all these virtual machines that it creates. It's so that's why when you send this thing with the app with the guest operating system with all the dependencies as compared to just this small container without the operating system, there is a big difference on the machines that these containers or these copies will be deployed, because in the case of virtual machines it's going to be a lot of overhead. It's really going to affect the performance because it's using the resources of the server on where it will be installed at the end, or where it will be used. And in the case of Dockers, it's just perfect. That's why the Dockers are very popular these days, and this virtual machine concept is a bit outdated. Of course, there are many companies which are still using the virtual machines, but the Dockers are becoming more and more famous with time. And that's it. Thank you very much for listening. I hope you like the video. Thank you.